Alright, CNT125, Chapter 11, we're now working on the section on SNMP. So enterprise-wide network management systems pretty much all accomplish fault and performance management, and they're all going to use a similar architecture based around these pieces. Here's the main pieces that you run into. The network management station, the managed device, the network management agent, the MIB, management information base, and the actual SNMP protocol, simple network management protocol. So let's start taking a look at these pieces. First thing I want to mention is the network management station, NMS. The function of this guy is really to collect data from multiple devices at regular intervals. They call this polling. Bring all that together so that it can be displayed and used and synthesized, if you will. This could actually be on a workstation or a server. It does not need to be anything out of the ordinary. It could just be a workstation with network management software installed. And the idea of this is, think about your car. You have all kinds of different pieces and parts running in your car. Your dashboard is really there to try to bring data from all those things so that you can see them all in one spot. That's what your network management station is. It's bringing data from all the devices in the network to one spot so that I can see it, and that helps me make decisions on what's working, what's not, what I might need to fix. So here's your network management station. This is going to be talking to the devices and things in your network and pulling that information here so it can be displayed, and I can use that almost like a dashboard of my network. That's your network management station. And I might run things like Cisco Works. If I have a totally Cisco network, I might use a SolarWinds product for network management. I might use OpenNMS. This is what we're going to end up using in our lab to bring all the data from all the devices to one spot to look at and manage our network. The next piece I have is my managed device. Managed device is really any network node that I want to monitor in my network. I hate to say anything with a NIC, but it's almost that broad. It can be a router, it can be a switch, it can be a server, it can be a printer, it can be an access point, it can be a desktop, it could be an IP phone, it could be an IP camera. Pretty much anything that attaches to the network many times can be managed by your network management station. It all depends on what I want to monitor. If my business revolves around people printing things out, maybe it's a tax return office or something, I might want to monitor the printers to make sure that they're all working. I would need to know that because if there's a problem with one of them, I need to run out and fix it for them quickly. Each managed device may contain several managed objects. So if I say I'm going to monitor my printer, I might want to monitor a couple things in there, whether it be paper level, terminal level, processor, bandwidth, etc. Let's take a router or switch, for example. On a router, I might want to monitor the different interfaces. I might want to monitor the type of traffic moving through. Those would be different entities I can manage about that device. Okay, those would be different objects I can manage about that device. And each one of those has an OID, object identifier, associated with it. So I might manage my router, but then I might have a couple OIDs that I'm monitoring in there. This interface gets an OID. This other face gets an OID. This type of protocol moving through gets this OID on this device. And here's our different managed devices. Here's our laptop, a printer, a switch, a phone, a router. These would be all managed devices that I'm monitoring in my network. And then as that traffic starts moving around, there's OIDs. That's these big long number strings. 136141921. That OID identifies a specific thing on that router. It might be the Ethernet, Fast Ethernet 00 interface gets that OID, but the Fast Ethernet 01 gets a different OID. That way I know the difference between those if I'm monitoring them. The management agent, this is the actual the software, if you will, that's running on that device. So each managed device runs a network management agent. That's a software routine that collects information about that device and then processes that and sends it to your network management station. So on my device, on my laptop, I have the agent running. That's the little piece of software that's designed to run and collect that data and then start sending that to the network management station. That's your agent. That's your network management agent. When we do our network management lab, we are going to configure the agent on things like our routers. So it passes that information to our network management station. Here's a little teeny chunk of network management config on a router, giving you an idea. When I'm configuring this stuff, I'm actually configuring the agent on that router to start collecting, processing, and sending information. There's the MIB management information base. This is a list of objects managed by the network management station. So it's really a database of information, management information. It's a database of, designed to be, I should say, a database where I'm collecting all the information and organizing it so that I can reference that. So each little device, each switch has a little mini management information base, stuff that it's maintaining. And then the management station also has its own. Once it collects all the information from the managed devices, it builds its own little database of information as well. When you start running something like OpenNMS, we actually have PostgreSQL running, SQL Server. It's a database running to collect all that data that we can use that for monitoring the network. And actually, here's a little chunk out of OpenNMS showing you the MIB compiler. Okay. Last piece of our simple network management, the pieces of our architecture, is our simple network management protocol. The protocol itself that's going to communicate this information back and forth between things like routers and switches and your network management station. The agents are going to communicate this information back to the network management station using one of several application layer protocols. Most are going to use SNMP. SNMP is part of the TCP/IP protocol suite, and it's going to typically run over UDP over ports 161, 162. So thinking back to your security, those might be some ports that you need to leave open for traffic moved around your network. There is SNMP version 1, 2, and 3. Many networks are still using 2, migrating to 3, if you will. And here it just shows you some Wireshark of SNMP traffic moving around the network. Here's SNMP. Okay, as I look at it, I start seeing Ethernet IP UDP header. There's UDP. Here's your port number 162. And then I also see down here SNMP. There's your application layer protocol right down there. All right. SNMP has a couple different types of packets, if you will, different types of information it sends. It actually has a get request, get response, get next. Get request is the network management station says, can you give me data agent? And then the response is just that agent sends a response back to the network management station. SNMP might do a get next, meaning, hey, your next line of data, send that to me too, please. And then it would start responding with that. And actually, here's a get request. Here's a get request particular type of SNMP packet. There's a walk, and that is really just a series of, hey, get next, get next, get next, so it can actually pull all the information from the table. And last is an SNMP trap. A trap is I set a criteria on my device, like a router, and I tell the router, hey, if this certain event occurs, don't wait for me to ask, you tell me right away. So I might tell the router, hey, if this particular interface goes down, gets turned off, goes down, immediately tell me, using one of your other interfaces, immediately get that information to me and let me know this port went down. That would be a trap. That would be a trap. We're actually going to see those when we have our network running. Here's the SNMP protocol again, UDP, port 162. Here's an SNMP trap. This is indicating a certain event has occurred, letting me know, or letting the network management station know this sort of thing has occurred. You probably want to be aware of that. And there it just shows your SNMP protocol moving back and forth. There's several ways to view and analyze your data. With a line graph, this would show events or trends over time. Maybe this is over months, hours, days, weeks, months kind of thing. Maybe show me busy times of the week or busy times of the month, so I can start using that information to help with quality of service configuration of my networks. And I also have map functions. This is actually a map of a network I had running to prepare for you guys for lab. that you're going to do with this chapter. I had broken a specific link on my network, and you see those two nodes, these are actually two routers. They have a little flaming symbol next to them indicating, hey, I'm broke, fix me. And that would be useful. That information is actually useful, cluing me into there's a particular problem. And I can even have larger area maps too, indicating links between certain sections or certain branches of our company or certain links of our company, letting me know things are functioning or not functioning. Your network management applications tend to be very flexible, but they are challenging to configure and fine-tune. We're going to find that out when we do our network management lab. We are going to do a lot of configuration just to get the thing up and running, but it would really take days, weeks, and months to start tuning this to give me the information I want. And you're going to continue to tweak and tune, because you might say, hey, we're done collecting that info. I want to now start collecting this info. Hey, we're done collecting that. So you're going to continue to be tweaking and updating this thing, and really trying to choose or narrow down what type of stuff you want to collect. It could collect way more than you want to process. So dealing with that and processing all that. Baselining. Okay, so baselining needs to get done. Sometimes you'll use a specific program to do this, things like a SolarWinds product here, that is going to measure statistics over time that I might know during the course of a week. This is normal bandwidth utilization. I can now use that and reference that for another event that comes along. Maybe another event comes along, a sale or a specific type of day where we're processing lots of applications, and they say, oh, the network's horrible. You can take a snapshot then and compare it to your previous data and be like, well, actually it's not much different. Or you might say, yeah, it is dramatically different. And that might be justification to say, hey, we need to upgrade this part, we need to change this part, we need to adjust the quality of service here, we need to limit this type of traffic there. Okay, that would be useful information to start gathering. And here it even gives you an example of things that you might be recording: bandwidth utilization, certain particular errors that you have in the network, certain protocols you run, number of users logged on per day, per hour of the week, and so forth. And all that information can be used to help with tuning your network, adjusting performance in your network, that sort of thing. And again, this might even be justification to allow a certain type of traffic through that was not before, or say no, we really shouldn't be allowing people to stream blah type of traffic through the network during the course of the day, whether it be video or audio or whatever it happens to be. And again, I was just saying here, you're going to compare that to now, information you have now plus past data, and use that to try to predict, as well as maybe even justify certain things that you're doing or need to do. New traffic patterns can vary considerably over time. They can vary through the time of the day, the week, the month, etc. Here is busy traffic patterns during the holiday season. That might be completely normal for that type of network because of sales, but it might be also unexpected too. Assuming all the new users would share the same network usage habits as the current users. Maybe there's a whole new team of people brought on that are doing a very special project that is using a lot more bandwidth. That would be a little bit unpredictable. And here is a bunch of different programs that can help with baselining. Some are free, some are expensive, but these would be things that you might be running or using to help with this, to help with baselining traffic on your network. Gather that, utilize it, and you're using it things like this, looking at utilization, error rates, packet drops, jitter, that sort of stuff. Again, all in the name of tuning your network. Utilization, how much is getting used; error rate, how many sorts of things, packets or frames are getting errored. That might be because things are too congested, they're dropping them. Again, here's packet drop. Again, if things are getting too overwhelmed or congested, things like routers and switches might be dropping those packets. Jitter, if you have a lot of audio or video and you have, again, things are overwhelmed, those packets might be getting a little jittery on our audio signal and video, and you would need to adjust that, adjust your bandwidth to handle that. All right, we're going to come back in the next podcast and talk about our network traffic, managing our network traffic.